The reason I'm recording today's video is to demonstrate how powerful GPT-5 is in performing a complete simulation of an electromagnetic problem, specifically an antenna design problem, a small half-wave dipole. The key point is that I do not guide it with engineering advice. It independently generates the C++ simulation code. I then run the code, provide the results back to GPT-5, and based on those results, it can analyze the electromagnetic behavior, assess whether its methods were correct, select alternative approaches if necessary, and adjust simulation parameters accordingly. Writing code is, of course, one of its strongest capabilities. I will also run the same tests with Grok and DeepSeek to show how GPT-5 compares against the competition. Now here, I do not want to present the simulation codes. This is not a video for antenna design or writing code. I just want to show how great GPT-5 is, and without receiving any engineering advice, it can go in and basically do the job by itself. Okay, let's get started with the GPT-5 itself. So I start the conversation by asking it to develop a full and complete C++ code to apply method of moments to simulate a half-wave dipole antenna with a given length and thickness of the wire. So it gives me the code. Here's the code, and of course I come to my terminal. I run the code that it gives me. There has been multiple codes here, so so if you see here, we start from version 1, then go to version 2, and it is at the version 9 that it gets the problem completely, solves it. And so if I want to show you one of the codes here, GPT. Okay, this is the first one that we start with. So I just want to quickly demonstrate that how it starts provides a very complete code calculating the input impedance and such. All right. And then it is printing out some of the results, and then it is these results that I give GPT-5 as feedback. So let's go back. I run that code, and I run this code, but I encounter some errors. So there are some compiling errors. It gives me instructions how to fix that. All right, I do those fixes. I run the code again, and part of the results is this input impedance. I give the input impedance back to GPT-5 saying that this is it. It's very wrong, of course. It understands that it's wrong. It analyzes the code and tries to find out why it's wrong. It's not, at this time, it's not going in the right direction. So it gives me a code which, of course, encounters another problem. So I run the code, and I just copy paste the results here without any engineering advice from myself. So these are the values, very high. So here, just a quick point that at not exactly half wavelength, but at 0.48 wavelength, you're supposed to have a reactionary part that's almost zero, the reactive part, and this part is going to be way less than this one. So it analyzes the results. Here's it's taking a very interesting turn. It switches back to using Pocklington's integral, which is quite good here. It's going to have some additional problems. So it's going in the right direction, at least for the real part. So I run the code again, and I provide the feedback. All right, it seems like, well, it shouldn't be near zero. It should be almost 70 something ohms. So it understands, it analyzes the code, the method itself, changes the parameters, and okay, I run the code and give the feedback. Now this is in this change is in the right direction. All right. Okay, it understands that. It says, great, those numbers look sane now. All right, so it's understanding that this should be, there's a bit short of resonance. Okay, so let's see how it's trying to fix that. This level of agreement is what I'd expect from Pocklington, plus pulse point near panel high order quadrature. The okay, here, mesh checks. All right. All right. So here's what it's recommending me to do. It's this change here. I apply that, and it gives me the code again, and okay, it's improving, but not quite. It's very slowly improving. So what happens here is that that improvement continues, but very incrementally. Now here's the interesting part. It says try a micro sweep around 0.8. All right, and I do that. And it is by finding that micro sweep that as you see here, when it recommends to do a sweep, so it comes back, it slowly improves the real part. It's coming close to that 72 ohms, and this one is going down. So here is the point that I interfere myself, because I find that the code is, it's a nice sweep, but it's going to take longer time. So I just interfere and make it close, force it to be equal to 0.48. And then input impedance is perfectly almost 72 ohms, and this is nearly 0 ohms. So I think this is a big problem, although it's one of the simplest of antennas. But if you ask any antenna engineer with even a master's degree to write this code by itself, probably won't be able to. It's not that easy, but GPT-5 could do the same. Could do that in just in a few minutes, in 9 iterations. So we tried the same with DeepSeek. So I just want to show you how many iterations of DeepSeek we had. I came up to 10 iterations here. After 10 iterations, I decided that this is not going in the right directions, so I simply gave up, and it wasn't coming anywhere near the real answer. So Similar story with Grok. I gave it 12 chances, so it comes up to version 12 here. But at the end, again, I couldn't get the answer for input impedance, the answer that I wanted. I didn't get that, so I gave up at that point. Yeah, thank you so much for watching this video, and hopefully you'll be able to use GPT-5 in a very useful way.